Hi, Shrikant, can you hear me?
Hi, sir. Good evening. Yes, I can hear you.
Good evening. How are you?
Good morning, sorry.
No, that's okay. It's good evening for you. How are things going?
Good, sir. I think
Very good.
people are just joining in.
Yeah, that's okay. I just thought I'd check the connection because been having some problems with my speaker and microphone.
Yes, sir.
Yeah, it's switching back the defaults all the time. It's just when I plugged my earphones in today, it switched it back to external.
That's right. Okay.
And then, let's see. I don't know. It's okay. It's working now, so I'm fine.
I think maybe because of some software update or something might be required.
God only knows what these people keep doing. Then it's been raining a lot out here.
Yeah. How the cases there, sir, of COVID?
Very bad. It just keeps on increasing all over the
Oh,
country. We have the honor or dishonor of being the largest number of cases in the world. So things are not good. But anyway, I mean, we're just staying home and
I think Florida is badly.
yeah, Florida.
Yes.
I mean, now it's coming to the Midwestern states also. It's all over the place.
Oh,
The only place I think that's not doing as, is the Northeast because they had it first. So New York is doing fine, or at least the number of cases are
okay.
lower. My son,
Right.
he lives in Maine, and the number of cases in Maine is not bad.
Uh-huh.
It's okay. But bad all over the place. How are things in Pune? Oh, you're not
Pune
in
to
Pune.
cases.
Sorry, you're
No, I'm
you're
in
in
Kerala
Kerala.
now.
Yeah, how
So
are the
cases,
cases there?
there are around 2,500 cases per day, sir. So yeah, it's increasing. It was 500, then it increased. Now actually, they're saying that it will reach around 10,000 cases per day because there's a community spread.
I see.
Hello, sir.
Hello, how are you?
I'm good, thank you.
Is it
Satyam
Satyam?
Anand, sir. Yes, sir.
Yeah, Satyam, we were having some problems with your connection last time. So today you're coming through loud and clear.
Yeah, sir. Thank you, sir.
So where do you live, Satyam?
I'm living in Kolkata, sir.
Oh, you're from well, I can't call it exactly my hometown, but I do have a home.
Actually, I was born in Jamshedpur. Last time you were introducing yourself, so I overheard.
Oh,
And
really?
my father was with Tata Steel. He retired 3 years ago.
Oh, wonderful. I was born in Jamshedpur. I grew up there. But did
Uh,
you go to Loyola School too?
yes, sir.
So I went to Loyola School, and Jamshedpur has been a lot of fun for me.
Oh,
So
well,
I went
exactly,
back.
yeah, true, sir.
I went
Good to.
back there to Jamshedpur about 3-4 years back. We had a Loyola School reunion for our batch. We graduated in 1971, much before you guys were born. Um, and it was wonderful being back in Jamshedpur. Do you go to
Good place, nice place.
Do you go to Jamshedpur?
Yes, I was there 4 months ago, but now all the train services have been suspended, so I'm not able to commute between the two places.
I see. Okay.
Even now, my parents asking me not to come, so that is why I've not been able to go for the last 4 months.
So your parents still live in Jamshedpur?
Yes, yeah.
Okay. So let's get started.
So we have one new person, some Varun Singh. Last time,
Is Varun Singh here?
yes, I think so.
Varun, do you want to introduce yourself, please? Because we had some introductions last time, and Shrikant told me that you just joined. So would you like to introduce yourself and just tell us a little bit about your background and where you are from and what do you expect to learn from this program.
Yeah, hi. So I'm Varun. I've completed my graduation from BITS Pilani, Hyderabad. So I graduated in computer science, and since then I've been working at VMware in Bangalore. So I like this program because regarding artificial intelligence and machine learning, I thought that the projects would give me a lot of hands-on experience.
Okay.
Yeah, so I thought this was a good fit for me.
Okay, very good. Thank you for joining the program. And I hope we would, live up to your expectations. And before okay, so let's get started. So last time I was talking about um, structured data management systems, right? So we first talked about uh, data analytics. What is, I remember the four constructs in data analytics, which is, one is the data management. The other is the data models that support the analytics. The third is the technology that supports the analytics. And fourth is the domain areas in which the analytics are applied, right? So those integration of those four components really make up a data analytics environment. So then we said, okay, we will start with looking at the data management capabilities. Not that the focus of this particular program is on data management, but we know that data management, without data management, really data analytics will not make any sense. And in fact, you will find in industry, one of your biggest challenges will be to get the right kind of data to actually do your analytics, because it doesn't matter how many models you know, basically, to do your analytics. If you don't have the appropriate data, you're not going to go anywhere with it. So I would ask you guys to focus on the data part of the analytics environment as much as you would focus on the models part or the analytical part of the data analytics environment. Okay. Um, in fact, I would say that you should, and I've noticed this tendency with students to, and I also did the same thing. It's not like I didn't do it. There's a tendency for students to basically learn as many algorithms as possible, hoping that life would get better if we knew a more superior algorithm than the one that we know. Unfortunately, it doesn't get better. What happens is you are only limited by the quality and the and the underlying structure that might be there in your data. So for example, years back, I had done a study on the prediction of targets, financial targets for mergers and acquisitions. And I ran some multi-layered neural networks. I ran some logistic regression models to see how the data, how I could use the data to capture an underlying model that might exist. It didn't really matter what model I used. I essentially tried to tweak all kinds of things: the number of layers, the number of the independent variables, the number of variables in the intermediate layers. All kinds of manipulations were done, basically. But the data was, at the end of the day, my prediction capability was only about 55 to 57%, something like that. But if your prediction capability on a holdout sample is in the 50s, really you might as well toss a coin, especially if it's a binary target that you have, right? So, so just because you know all kinds of algorithms, it doesn't make you, solve or address the problem better. So focus on the data, focus on the quality of the data, focus on the underlying patterns that might exist on the data set. Okay, do a lot of pre-analysis on the data before you actually go out and basically say, okay, I'm going to apply this deep learning model and it'll essentially solve all my problems. Hopefully the faculty members who will be coming after me will be focusing on that aspect of data analytics as to the as to, and you will also see it in your projects that I'm going to be assigning to you. You will find that, you know, the model that you use will actually have an impact on the prediction capability, but the impact will be marginal in most cases. Okay. And so just because you're using a much more complex analytical model to model that data, it doesn't necessarily mean that your prediction capability or your underlying pattern analysis capability is going to improve. Okay. Now, with that, are there any questions from what we discussed last time? Can all of you hear me? Everyone, you know, am I audible? The video is clear and everything? Okay.
Yes, sir. Yes, sir.
Okay,
Yes,
good.
sir.
So I'm going
Yes,
to
sir.
share my screen. So last time, what we were doing is we said, okay, we will model structured data. And the way we will model structured data is to use relational models. And relational models are relatively straightforward to understand because they're in the form of two-dimensional tables. All of us are familiar with, you know, how two-dimensional tables look like. You know, I'm sure all of you have used, you know, Excel spreadsheets to know exactly what columns and rows are and things like that. Fortunately, the relational model, as contrasted to a lot of other models, is a relatively simple model to understand, okay? But one thing that I did point out the other day that just one second, I want to, yeah. So one thing I wanted to point out the other day that although a relational table or a relational model is a collection of tables, these tables are related through what is called an entity relationship model, okay? So underlying a relational model is always, you know, if it's a true database, there will always be an underlying entity relationship model that will show you the relationships between the different entities that exist in that model. And these entities, as we saw last time, were essentially you know, objects of interest. Okay, some of you asked me a question regarding object-oriented systems. So think of them as you know, objects of interest. These entities like regions or users in a LinkedIn environment. And then these objects of interest are then converted into relational tables. Then, and the relational tables will essentially store information regarding users through using attributes and fields. But in addition to that, the tables are also related to each other, and these relationships are established using primary keys and foreign keys, okay? And as I told you last time, a primary key is something that uniquely identifies a row in a table, and a foreign key is an attribute or a field that is a primary key in some other table in the entity relationship model. Does anyone have any questions related to this? Okay, so then we said, once you have the ER model, then you have a set of relational tables. How do you actually implement this in a database environment? Well, in that case, you will have to go to commercially available relational database management systems. And we talked about, there's Oracle, there is MySQL, which is a open source database management systems environment. Then you have Microsoft SQL Server, you have IBM's DB2, and so on and so forth. So there are several of them. The most popular among them is, of course, as you all probably know, is the Oracle database. And so they are all relational models, and in some cases they are object relational. And as I was explaining to you, that although there was a push towards object-oriented databases, they became essentially a combination of identifying classes and objects in the relational database environment. So what really happened was relational databases were extended to adopt some of the object-oriented properties like inheritance. Now, having done that, then we said, okay, let's move on to SQL. So in SQL, the structured query language that is used for querying data from relational databases, we basically have four broad categories of commands: queries that allow you to retrieve information, data manipulation that allows you to insert, update, and delete records or rows in a table, data definition that allows you to create the structure of the table and manipulate the structure of the table in a form that you might want. And finally, security is something that SQL also has, which allows you to grant access to various components of the table to different users. So we first started with the select command, which basically says, how do you query information? So select some data from table where some specific conditions are met. Then I gave you an example of a simple select command: select star from users. Star indicates all rows from the table. So it lists all rows and columns from the table users. And then select from where, so select user ID, first name, last name, summary from users, where user ID equals U1, okay? So this essentially lists all the user IDs, the first names, last names, summary information regarding a user from the table called users, where the user ID is equal to U1. Now, I also wanted to let you know that we have Dr. Ajay Kumar, who will be, remember I was telling you that there will be someone who will be supporting you with the MySQL assignment, as well as the 3 projects that I have assigned. The project 1, which is the predictive analytics project using R, and project 2, which is the machine learning project using Python. And finally, the capstone project, which basically you will have to do using Python, that will be in an application domain of your interest. So for the capstone project, I told you that Dr. Guntish from Mahindra and I will be working with you to support you on the capstone project. But we also needed someone who was much more hands-on and technically skilled. And Dr. Ajay Kumar will actually be helping us do that. I talked to him yesterday. I explained the expectations from the program and from the students. And so he will work with Shrikant to set up a time for you so that you are introduced to MySQL and how to actually set up MySQL on your laptops and do the assignment. In the assignment, you will notice that there are some aspects of it that makes the MySQL environment, or for that matter, the database environment, somewhat complex. Okay. Now, you will need some handholding on that. And also what you will also need is that you may have to work on the projects jointly. But when I was talking to Dr. Ajay Kumar yesterday, he said that it might be easier to administer the assignment on individual laptops than basically to do it in a group. And I agree with him on that. So I think the assignment will be done on individual laptops. Now, in terms of when the assignment is due, I will not be able to give you a due date right away. I think the first thing you need to have is a class with Ajay Kumar, who will actually go through with you on MySQL. Once you're comfortable with the environment and know how to install MySQL on your machines, and he will tell you how to load the data, how to create the tables, and so on and so forth, you should be able to do it on your own, and he will essentially set up a due date for the assignment. So at this point of time, although I've given you the assignment, okay, I'm not setting up a due date for the assignment. Okay, are there any questions on this process of doing the first assignment?
Sir, good morning, Krishna here. Sir,
good morning again.
I just wanted to know, is there any particular database I was trying to download MySQL, and I was getting PostgreSQL download everywhere. So is there any particular database that we should use, or is it MySQL or anything that you prefer? Or
my preference would be MySQL, and the reason for that is it's open source, it's readily available, and that would be my preference. And also, if you understand the MySQL environment, as you move along in the data analytics environment, you will be able to do a lot more with the MySQL environment than you would be if you were basically in a, say, let's say an Oracle or a DB2 environment. Now, installing, let's say, Oracle or DB2 or anything like that on a laptop, those kinds of things are much more complicated than installing MySQL. So my preference at this point of time would be MySQL. However, as I said last time, if people have other databases installed on their machine and they're more comfortable with that, they're welcome to use that. I'm not going to tie you down to a particular environment. But if you have not used another environment, let's stick to MySQL. So the class will adopt MySQL.
okay, sir. Thanks.
Sir, Srijit here. Hi, sir. Sir, actually, I have two doubts. Actually, this I can see in net there is a already internet IDE is available for MySQL, so that you don't have to download. You have to do the program there. So, whether are you preferring that, or
again, I would leave that to you. So the problem is this, basically, there are so many different environments in which these things can operate that it's impossible for me or Dr. Kumar to know what all these environments are. My focus is really on one thing, that you need to be able to understand how to create a database, how to create tables, store data, retrieve information. Which environment you do it in, basically, I'm not going to enforce any constraint on you. So if this IDE environment works well for you, absolutely, please go ahead and do that. And also, if you can get technical support, so let's say in your organization, someone is there, basically who's very familiar with that environment, go ahead and do that, because I'm not trying to make you technical experts on database administration.
second? Yeah, I understood, sir. Second, I saw your assignment. Actually, this data which has to be fed on this particular assignment, is there some random data we can prefer, or you have any data already available which we have to fix it in that table?
That's a very good question. I am trying to collect the data that we used last time, okay? And the data is there. So let me explain to you the challenges that I'm facing right now in getting the data. Last time what we did was we created a MySQL environment in an AWS server, where I basically had someone create the tables, create the relationships between the tables, and load the data into those tables. So so the tables were pre-loaded, basically, so you didn't have to worry about that. But in this particular environment, I'm actually asking you to create the tables. It's a little bit more challenging, but to create the tables and load the data and so on. So I have asked, this gentleman's name is Surya, and I've asked Surya to give me the data in Excel spreadsheets, which he should be able to do if he still has access to that particular database on AWS. Even if it does not, he should have access to the original data from which he had loaded the tables. but I'm working on that. So I will hopefully be able to give you the data using Excel spreadsheets. Okay.
Okay, sir. Thank you.
And also, I'm also working with Dr. Kumar, Dr. Ajay Kumar, to see what would be the best way to deliver the data to you. And so you will have a solution to that problem before we expect you to actually create the tables and store the data and so on. Okay, any other questions? Now, since you asked me about the data related to this, for projects 1 and 2, the other 2 projects, remember the predictive analytics project, which will be given to you in a week or so when you start the predictive analytics component of the course. The data for that and for project 2, which is the machine learning project, I already have that, and I was trying to send it to Shrikant yesterday, but I don't think I have done that. But I have that data, so that's not a problem. It's the MySQL assignment that I sort of introduced at the last moment, that for which I don't have the data, but I will get the data, and if not, I will find a way to create the data. Okay. Any other questions?
Yes, sir.
Please go ahead. Yes.
Sir, it's Khurshid Alam. Good evening, sir.
Hi, Khurshid. Good
Yes.
evening.
Sir, I saw your assignment yesterday. For that, I have a doubt, like how to interlink 2 tables.
Okay, so remember I was telling you that the interlinking is not an explicit process in relational databases. The interlinking is an implicit process in relational databases. So, and I will not go into too many complications related to interlinking, but I just tell you how the interlinking is done. So if you look at this table, users, user ID, first name, and so on and so forth, the user table is linked to the regions table, right? So how is the linkage actually done? So you remember in the ER model, we said one region has many users. So it is called a one-to-many association between regions and users. So when you have a one-to-many relationship between 2 entities like regions and users, what we normally do is we take the primary key of the regions table, add it as a foreign key in the users table. So what you notice is the users table has a key called RID, which is the same as this RID. This field is exactly the same as this field in the regions table. So that is how relationships are established in relational databases. They are implicit relationships. Okay. Now that is not the only way to establish relationships in databases, but for example, there are other types of databases where the relationships will be a lot more implicit. Once you've actually played around with this and you've done the assignment, I'm going to have one more class, which I'm going to ask Shrikant to schedule later on when we have time. There are some complexities involved in linking the data implicitly, especially when you are dealing with large volumes of data. Okay, this is probably one of the biggest disadvantages of relational databases. And when you get into big data type environments, you cannot really use just these implicit relationships. But for that, I need to have one more class which will essentially explain what the challenges are and how they are addressed in a big data type environment. But that requires going into a little bit more depth into how the data is actually stored. But for now, to answer your question, Khurshid, it's basically just the use of a foreign key and a primary key. So this is called a foreign key, this one, and this is a primary key in the table regions. Does that answer your question, Khurshid?
Yes, sir.
And since you asked that question, if I want to retrieve data from both the users table and the regions table, I will have to join the users table to the regions table. Okay, and even joins in SQL is also implicit, like I was trying to explain to you the other day. So here is an example of a join. If you notice, there is no explicit join command, although you can have an explicit join command in versions of SQL. But I'm just saying, in fact, this is a perfectly valid SQL command. But you notice that there is nothing called a join over here. It simply says, give me data from these three tables, users, industry, and positions. And actually, if you did not have the rest of this, if you did not have the rest of this sort of clause in the command, the query would still work. And what the system actually does in a relational database is it creates what is called a Cartesian product of these three tables: users, industry, and positions. Now, where does this term Cartesian product come from? I think if I remember, I told you all the relational databases look very simple. They're actually based on set theory. And those of you who are familiar with set theory, you'll probably understand what I mean by saying Cartesian product. It's really all possible combinations of the rows in these three tables. But even if you don't understand, it doesn't matter, basically. What I'm trying to say is, if you in SQL or in the relational database environment, joins can be implicit, basically. They may not be an explicit command instructing the system to join. Okay.
So one more
Anyone has any
thing.
question? Yeah, sorry, go ahead, please.
One more thing, what I want to know about clauses. What is the use of having clause in SQL? Yesterday, day before yesterday, you have explained, but somehow I didn't get properly. So could you please again with that clauses.
So if I understand your
Briefly,
question,
sir.
yeah,
Briefly, yes, sir.
yes, sorry, go ahead, please.
Briefly, just explain that what is the use of clause in SQL? Because when I was doing your assignment, many times I saw this clause is not in your SQL command. Something is coming over there, error messages. So I need to know what is the clause.
Okay, so clause is a computer sciencey term used for a section of code. Generally, that section of code is a condition code, basically. So if I often refer to this part of the SQL command as a clause, because if you notice, what I'm doing is essentially I'm putting a condition to an outer command that essentially takes place. So that's why I use the term clause, but clause is a very generic term for a section of code that, that is conditioned upon, it's really, another word for it is basically a condition statement. Okay, so clause by itself doesn't mean a whole lot, except that it is a very generic term used in computer science, interchangeably for a lot of different things. So if in an error message it says clause XYZ, you'll have to look at that section of the code where the problem might be occurring, and that's what it's all pointing out to you. And in SQL, generally the reference is to the where clause. We call this where condition as a clause. Okay.
Thank you, sir.
So, okay, after that, we did the join command, then we did the order by clause. Again, I'm using the word clause, basically that, again, this is a section of this particular code where order by is a subsection of that particular larger clause. So clause is used, as a reference to a section of code, basically. So order by last name is a clause in this particular query that orders the information by last name. Another command, which we, at this point, we stopped last time, it's a group by command. And you will notice that the SQL can do a lot of things by very simple commands. And Python also, when we go into the analytics part, you will also see the same thing. In analytics, Python can essentially do a lot of stuff using libraries, basically, which is a simple command. But underlying that, there's a lot of execution of code that takes place. So even if a command looks very simple, do not assume that the computational complexity of the command is also simple. So here is an example of that. Suppose I wanted to find out the average number of connections each individual in the LinkedIn profile database that I have. So the average number of connections that each of the individuals have, right? So the way to do that is to use what is called a group by clause or a group by command in SQL. So select RID, which is the region ID. Oh, I'm sorry. The question was list the average number of connections for each region, not each user. So for each region, I want to find out the average number of connections. So select the region ID, comma. Here's what is called a built-in function. It's called average. There are lots of built-in functions in SQL. One is average, sum, min, max, and so on and so forth. So average is a built-in function, and it will compute the average of the column called number of connections. It will get this data from the table users, and at the same time, it will group the information by region ID. So the command is relatively straightforward. 3-line command. But let's look at what might actually be happening underlying this command. So suppose you're a massive LinkedIn database with 10 million records. And let's say there are 10 million records in this region table. And let's assume that, that there are 100 regions in this table, in this information, this users table, basically. It'll have to, the system internally will have to go through one record at a time on the regions table, on this table called users, search through 10 million records for a specific RID. So let's say region R1. It'll select all the records in region R1, compute the average by summing all the number of connections and then dividing it by the count of the regions within that particular, for that particular region, and get you the average for just one region ID. It'll have to repeat the process for the second region ID and the third region ID and the fourth region ID up to the 100th region ID. So a simple command like this can have massive computational complexity, and it can actually shut down a computer or shut down a large computing environment by someone executing a command like this on the fly on a very large database. Is that clear to all of you? SQL can be very powerful, relational databases can be very powerful, but it fails miserably when we have very large volumes of data, especially when you want to compute commands on the fly.
Dr. Sen, I have a question.
Yeah.
Can we do arithmetic operations on the inbuilt functions that we have? Like maybe like half the average of the number of
Yes,
connections?
very good question. Yes, you can. So for example, you can say 0.5 times. So 0.5 times is basically an asterisk. 0.5 times average number of connections. Yes, absolutely, you can do that. Or suppose you have two columns, let's say price and quantity, and you want to multiply the two column values, you can simply say select price times quantity, price asterisk quantity. So I'll just write it out for you. So price is, let's say P, and asterisk is basically the star. So you can simply say P times Q, and that will work in the select command. So you can say select P star Q from table XYZ. So yes, you can do arithmetic expressions on the select clause. I mean, the select portion of the command. Okay, any other questions?
Yes.
Yes, please go ahead.
Sir, the output of this query will be resulting in a new table being formed, or it will just display the result?
Excellent question. All results of SQL queries are also in the form of tables. Okay, and I will again not have time to basically discuss the problem with that. You have to there is one basic construct in relational databases. Relations will have to have atomic values in a cell. What do I mean by an atomic value? So if you take the row and column intersection, there has to be only one value in a relation. If you have multi-valued items in that particular cell, relational databases will actually fail. So the result of a relational query, like in SQL, is also a table. So the number of values in a cell will also be single valued. So in this particular case, the result will be two columns. The first column will be region ID, and the second column will be a virtual field, because that field doesn't really exist in any of your tables. It'll be just a number associated with RID, but only one single number. So one quick way to check whether your SQL command is correct or not, if in a command, basically for some reason you have a multi-valued, question that you're asking in that select clause, it'll essentially give you an error. So I'm glad you asked that question, because that is something that we would have covered in a more elaborate database course. But yes, so you expect the output to have a single value in each cell. So since I said there are 100 regions, there will be basically a number of rows for this output will be 100 rows and 2 columns. The first column will be the region ID. The second column will be the average number of connections. Any other questions? So, SQL can become more and more complicated. You can have, in a group by clause, you can essentially also have something that you can use as a selection of the output of a group by query. So for example, using something called a having clause, the having clause is this clause out here. The having clause actually will work primarily within a group by environment. So when you do the following, select a.user_id, count star. So the question is, list all users in the database who have at least 3 positions held in industry. So what I do is select the user ID, count the number of positions. But in order to get the positions, I have to join the table users and positions. So which means I select users and positions, put in a join condition, which is a.user_id equals b.user_id. Remember, I told you last time, I can basically use aliases for the table so that, when I write the query, the query does not have to say users.user_id equals positions.user_id. I can simply say a.user_id equals b.user_id. And then I group by a.user_id. This is important. When you group this command, you basically have to also use the alias. You should not just simply say group by user ID. It needs to know which of the 2 user IDs do you want me to group by. And then the result can then be, now the result of this particular query up to this point will be user IDs and counts. But now I can instruct the system to give me only those results where the count is greater than or equal to 3. Okay. So there is another, so SQL can actually write relatively complex queries, and sometimes SQL queries you might have seen actually can, I don't know, well, you may or may not have, but those of you who have been working in industry environments in SQL, SQL queries can actually run into pages. And one of the ways to complicate or make the query more complicated or do more than just a simple select command is to nest the queries. Sometimes they're called nested queries, sometimes they're called subqueries. So let's say we want to do the following: list users who were educated at Harvard. Select last name, first name from users where user ID equals select user ID from education where school name equals Harvard. This is I mean, of course, this command could be done without nesting, but with nesting, what this is doing is it evaluates the subquery first. It evaluates the subquery, and the result of the subquery, if it can be used in the outer query, it will actually execute the query without an error. But suppose you arbitrarily have a query inside. So for example, suppose this produced 3 user IDs. The command inside the subquery produced 3 user IDs. This command would actually not work where user ID equals 3 user IDs. It doesn't work. So the assumption over here is it's going to produce a single user ID. So you can nest queries provided you know exactly what you're doing. So another complicated way of nesting queries, and this one requires a little bit of understanding. I don't, even though I'll be able to explain it to you in class, when you're actually trying to do it, it's going to, it's going to cause problems. I'll anyway try to explain it what we are trying to do using a subquery. So suppose I want to do the following. I want to list all users who have the maximum number of connections in each region. So suppose I have 100 regions. Operationally, it's very simple. What we are trying to do is, suppose we have 100 regions. We compute the max connection for each region, right? So that we know how to do using a group by command. So select max number of connections from users group by, region, and that would give me the result. But that's not what we are asking, basically. What we are asking is list all users who have the maximum number of connections in each region. So I want the maximum number of connections in region 1. I want you to match it with the user whose connections equal the maximum number of connections for that particular region. So do you understand what the query is asking you to do? Let's see how to write a query that will make it do it. But do you understand what the query is asking you to do? Or what we are asking the system to do, actually, not the query. Any questions on that? Okay, so if we understand what the system is being asked to do, that is compute or find the maximum number of connections for each of the 100 regions. And then using the maximum number of connections for each of these regions, starting with R1, then R2, then R3, and so on and so forth, match it with that user whose connections equal the maximum number of connections. How do we do that? Okay, let's start with the outer query. So select last name, first name, region name. We get this information from 2 tables, users A and region, users and region. So whenever, remember, when we have multiple tables, we use a join condition. So where A.RID equals B.RID. So far, straightforward, no problem. But then we want to say that the number of connections for this particular user should be equal to the maximum number of connections for that particular region in which this user belongs. Okay, so that means the number of connections should be equal to select maximum number of connections from users where region equals, if we knew what the region was, where we could simply say where region equals R1, but I don't know what the region is. The system knows what the region is. So now see something very interesting that will be done. I know that the system knows the region. So how do I retrieve that value from the system? There is an elegant way to get that value from that system. The value of the region ID for that particular user is actually the same as this value. isn't it? Do you follow that? So you see what is happening over here. Although it's one table, these select commands can work multiple times on the same table. So like you can join one table to another table, there is nothing that prevents you from using the same table twice in a particular query. So if I go and reference this a.rid, I am actually getting the region ID of the user that I'm actually querying in this outer query. So if I can reference that, I can reference that using the alias a.rid, and I make that equal to the current users table that I'm using, which I'm calling C, which is different from the users table A. So I'm using the users table twice, once outside and once inside. And how do I distinguish between the two? I give it two different aliases. The outer table, the first use of the table is called users A. The second use of the table is called users C. Now, if I say where a.rid equals, that means the RID that I'm looking at in this query is equal to the RID that I'm looking at in this query. If that is true, then I'm actually getting the maximum number of connections for that region, which is equal to the region that I am looking at for the user that has been referenced in the outer query. This one's a little difficult to understand, but I thought I'm going to throw that in. If you don't understand it, it's okay. It's not that big a deal. But I just wanted to show you that the level of data manipulation you can do using SQL and and relational databases is quite intense. But it has limitations when it gets to very large databases. Now, when I say large databases, I do not mean databases that exist in, say corporations like Mahindra or IBM, or I'm talking about databases that are even larger. For example, the social media type databases, where basically millions and billions of records are being created every day. Each transaction is being stored. So, for example, right now, if you look at my thermostat, basically at the house, if you look at the history in the thermostat that regulates the temperature in the house, you will see that there is a record for, I think it records the temperature every 15 minutes. So now imagine the number of Nest thermostats that exist in this country, or for that matter, worldwide, and imagine the volume of data that it's computing or storing. That kind of data, is not possible to operate upon, at least using today's technology in systems like this. We need other forms of data storage to do that, deal with that. You also need notice that we are not going to be running queries like this. What is the average temperature of this particular household? No one's going to do stuff like that, right? Okay, another useful query is the union query. The union query is nothing but basically taking two tables with common columns and appending them to each other. So list all users who have mentions of Baltimore in their summary, or they have been educated at Virginia Tech. So I do select last name, first name, Baltimore. I'll explain this to you shortly, this particular part. From users where summary like Baltimore. What is this query actually doing? Selecting the last name, first name from the table users where a summary, a field in that table, has the word Baltimore, and summary has a text string, so has the word Baltimore in it. So the clause that is used to essentially say that it has the word Baltimore in it is that particular clause in SQL is called like. It just says, does the word Baltimore exist in that field? Also, this percentage sign at the beginning or the end indicates to SQL or to the database that I don't care where Baltimore exists, whether it's at the beginning of the string or at the end of the string. So Baltimore can be preceded by any string before and after. So what is this thing in quotation marks? Now remember, I told you that in the select clause, you can use an arithmetic operation, price times quantity. You can also use what are called character string operations. Now computers can not only do arithmetic operations, it can also do character string operations. So this is an example of a character string operation. It simply says, display the string Baltimore. That's all it says. So in the output, I'll be able to distinguish between this row and the row that is coming in later on in the second part of the union clause. So in this particular part of the query, you'll get the last name, first name, and a string Baltimore. If the user summary has the word Baltimore in it, I want this output to be appended to this output. And this output, the second one, basically says, select last name, first name, Virginia Tech from users A, education B. Now in this particular case, I need a join because I need to look at the university name from the education table. So where A dot user ID equals B dot user ID and school name equals Virginia Tech. And this again is just a string. So if you look at the output here and the output here, they are very similar. They've got three columns: last name, first name, Baltimore, last name, first name, Virginia Tech. If the columns are identical in terms of the output that it's created, and when I say identical, what it means is it has the same type of value being displayed, then these two queries, the outputs of these two queries can be appended using a union clause. Okay, any questions on this so far?
So, sir, I just had a question. If suppose somebody has in summary Baltimore and he also has Virginia Tech and the education, so he will be repeated twice in this union, or?
Good question. Actually, he'll be repeated twice. Yes. But they'll have different indicators. It'll show in the first case, Tarun Sen, Baltimore, which means Tarun Sen has a mention Baltimore in the summary. And Tarun Sen, Virginia Tech would actually mean that he's also been educated at Virginia Tech.
Okay.
Okay.
All these strings that we use for searching, like percentage Baltimore, percentage, are these case sensitive or?
If it's a character string, generally it is case sensitive, but I believe you can put something in the like clause, and I can't tell you basically what that would be, to make it non-sensitive to the case. I'm sure MySQL has a way to do that. I don't know how to do that, but if you just put the query in like this, it will be sensitive to the case.
Will you be able to save the result of this particular query into a different table?
Yes. In fact, when you learn MySQL, there is you'll see, I forget exactly what the clause is. After the select clause, you can simply say select star from something, something, something. And I forget what the clause is, but there is something you can add at the end, which will actually store it in another table. But storing in another table really means a lot of activities, right? It's not as simple. It's actually has to create the table structure and then store it. And actually, there is another way to do it, and I'll show you shortly as to how to do that without creating a new table. Any other questions?
Sir, one doubt. What is the difference between this union and join table?
Completely different. Union is just appending records to each other. Okay, so for example, if the outer query, if the first query produces 50 records, the second query produces 70 records, the output will have 120 records.
Sir, one more question.
Which is not what we do in join. Join is very different. Join is we take two tables, but we compare, and these are two different tables. And we compare some of the primary key and the foreign key of the two tables. If there is a match, then only we select it. So the result of a join query could be one row, and that's it, because if it only finds one match. So completely different. The union query and the join query is nowhere near each other.
Okay, sir.
Sir, if we want the intersection of these results.
Okay, so what is the intersection query called? Okay, so intersection, now you're asking me something relatively complicated. So in relational databases, there are 5 basic operations, okay? And that comes from something called relational algebra. And those are, union is one of them. Product, or the Cartesian product, is the second one. The third is called selection, that is selecting a row. The fourth is called projection, selecting columns. And the fifth is called minus. Okay, minus is actually a set difference. Two sets, when you want to do the difference between the two sets, then it's called a minus. Using, if I don't exactly remember the formula, but I can send it to you. Intersection is actually not a basic command. Using product and minus, so if you do A intersection B, I think it's called A union B minus A or something like that. I can't remember exactly. So intersection is a result of union and set difference. So you can execute an intersection command by basically using a union and a set difference. Incidentally, the set difference is called minus. So instead of a union, if you had the word minus over here, it would actually create a set difference. So that is available in basic relational algebra. But set difference, or A intersection, set intersection, which is called A intersection B. Actually, I can just do a Google search also, and I can tell you. I think is equal to A minus A union B or something like that. But it's a combination of the two, minus and union. So to answer your question, you'll have to use those two commands. Okay, any other questions? Okay. Moving on, just remember that we had a situation where where we are trying to compare a single value to a set of values. It can be done using the in clause. The in clause is used to check for the existence of a value in a list of values. So for example, if I want to say select star from users, where user ID can either be U1, U2, or U3, then I can simply say where user ID in this list of values. Or using a nested query, I can simply say select star from student where major in select major from college equals business. So what this will do is list all the majors from the college equals business and select all those students where major is equal to one of those majors in the college of business. So in is basically, instead of saying A equals B, see again, this in is a clause that comes from set theory. A equals B basically says the value of A should be equal to value of B. A in B assumes that both A and B are sets and not individual atomic values. Okay? Any questions on this? Okay, so that gives you a general idea of the data query commands. Now I'll give you some examples of data administration commands. So here I'm going to use another relational database. It's called, this is for a health maintenance organization. Think of it in terms of a hospital, basically. It's got diagnosis as a table, physicians as a table in the hospital, patients as a table, insurance companies basically, and charge type. So every particular procedure has a charge, and the charge type information is there. And every time a transaction is created, is called an encounter. And what is an encounter? An encounter happens when a physician treats a patient and creates a charge amount, basically. So that's called an encounter in this particular environment. So again, another example of another ER model with relations describing that ER model. And these relations are physician for the physician, patient for the patient, diagnosis for diagnosis code and diagnosis name. Encounter is, if you notice, it's a composite key of encounter ID, patient ID, and physician ID, and so on and so forth. Encounter diagnosis is again basically essentially connects the encounters to a diagnosis. Charges is a table of all the different charges that can be used in this environment. Billing is a combination of encounter ID, type ID, and what's COID? COID is the name of the insurance company, and insurance company is company ID named iTelephone, etc. So the first command is basically, let's say you were in MySQL, you would essentially say, I'm trying to create a database, and this database is called the HMO database, or create a database HMO. And you give it a database name. Of course, there are lots of other clauses that need to be added, and Dr. Kumar will basically talk to you about that. But there is, in any relational database, there is a create database command that allocates a certain amount of space within which the database is going to be created. So that's the database command. The database command is not the same as create a table command. There are multiple tables in a database, as you know by now. Then basically you create a table. So for example, so creating tables is not easy because you have to give it the name of a table. You have to tell it basically, which is the what are the field names, what are the sizes of the fields, what are the types of fields, and so on and so forth. And then in addition to that, you also have to give what are called integrity constraints. So for example, if encounter ID is a primary key, you want to say that it cannot be null. That means you have to have a field in this particular record. And you also have to make sure that this field is unique. Now, date is a date field. PID is a character field, not null. Pat ID is character field, not null. Primary key is encounter ID. Foreign key is key ID, references the table physician. On delete, restrict, on update, cascade, foreign key, and so on and so forth. This Dr. Kumar is going to talk to you a little bit about that, but I'll just give you a sense of what's going on over here. The reason I'm asking you to create these tables is it gives you a better sense of what is going on underlying the table definitions. So you have to know a few things over here. First of all, you have to know what type of field it is. Is it an integer field? Is it a character string field? Is it a date field? Is it a decimal field? And so on. So the field type has to be known. Then you have to essentially know which one is your primary key. You have to tell the system that this is my primary key. Then you also have to tell the system which one are my foreign keys. So now you notice that you're explicitly telling the system what the connections are. Now you don't have to explicitly tell the system what the connections are. You can leave the connections, without these constraints. But if you do not have these constraints, when you create the data, it's going to cause some problems for you. I'll give you an example. So in this table encounter, we say foreign key PID references the table physician, which is another table, which is not this table, because this table is called encounter. So the PID in this table, which is this value over here, references PID in the physician table. And if I delete anything from here, then I cannot delete it until I have deleted the physician's record in the physician table. Because if I don't do that, okay, I am getting rid of data related to the physician that I do not want to get rid of. So that's called on delete restrict and on update cascade. So for example, if I want to update something over here, the PID over here, it should be cascaded down to the other associated field. That means the matching of the primary key and the foreign key has to be consistent. I don't think you need to get involved in all this. It's not important. These are things that a database administrator will be involved in. But for completeness, just to tell you what a create table command looks like, I use these. But for this particular program, don't waste your time on things like this, because again, like I said, you're not going to be a DBA. So data types: integer, decimal, character, varchar, data or date. The difference between character and varchar, again, if I have that lecture with you later on the physical aspects of a database, this will become clearer. But right now, let's assume that this is fixed. And this assumes that basically, suppose if I say varchar 100, it means 100 characters can be stored in it. But if you store only 50 characters, only 50 character space will be used, not the whole 100. And date is just a date field. And date fields, what are they? Actually, internally, they're numeric fields, numeric values that are stored. But those numeric values can be converted into month, year, and day. Okay, this one, just know how to create an index, give it an index name on the table billing, and tell me which key values are indexed. This also requires understanding of what a physical database is all about. And I'm going to not get into this right now. I just wanted to give you an example of an index command. But broadly speaking, what indexing is really doing is making it possible for you to retrieve billing records faster using these key values. And in order to understand why it's faster, you really have to understand physical databases. And let's not get into that. Alter table allows you to change the structure of a table. Again, this is something that you will not be doing, but just for completeness, I'm keeping this command over here. Now comes the insert, update, delete commands. You can insert one record at a time into the physician table by providing the values of the row in a construct like this. What will eventually happen is, obviously you can't insert one row at a time. This particular insert command will be executed in a loop that will allow you to load the data. This is going to be covered in the MySQL lecture that Dr. Kumar is going to do, to show you how to loop insert commands. But basic SQL has an insert command that allows you to insert one row at a time. Any questions on this? Although the command looks relatively straightforward, you have to remember that these values will have to match the table construct values that you basically created while using the create table command. You can't just arbitrarily put values in there. So for example, if you put in 428783456 and you did not put this character string indicator, it will give you an error. Okay.
So in case we are entering these values into the table, and we do not know what the column names are in the table, is there a way that we can see which columns are there in the table?
Yes,
the column types.
Yes, there are ways to actually look at the, I forget what the command is, but if you look up a MySQL, what you call reference text, it'll show you, there is a command that will show you the structure of the table. So for example, if you, this is the table called table uncounter, right? I think you can just simply say display table encounter. I can't remember exactly what the command is, but it's a simple command like display or something like that. It'll actually give you the structure of that table, which means it'll tell you what the fields are, which is the primary key, and so on and so forth. Okay, and that command sort of varies from one environment to another. But you can do a Google search on MySQL and see what the display command is for getting the table structure. Okay. I don't offhand remember what how to get the table structure in MySQL, but it's there in every relational database. Okay, now similarly, if a data row exists in a database, you can also update that data. And how do you update it? Basically, you say update followed by the table name, and then a set clause which says how should I update it? So set amount equals 123.45. So the amount value will be changed equal to 123.45. What happens if I don't have this where clause in this update command?
It's going to update for all records.
Right, it'll go ahead and update the amount field to all records. And that's why, these update, deletes, create tables and stuff like that. These commands are generally handled by the database administrator and not by end users like you and me. So it can be done. You can say update billing set amount equals 123.45. It'll go change everything out there, but you obviously don't want that change. So there is generally a where clause associated with it. And the where clause says encounter ID equals E1 and type ID equals T1. So it'll specifically go out to that particular row and change the amount value. Okay. The same thing with the delete command. It's a very dangerous command. If I say delete from encounter and I don't have a where clause, again, of course, it does give you a warning, but it'll actually delete all the records from the encounter table. So delete also should be qualified by a a clause that will specifically delete certain rows. And delete can also, like the update, can work on multiple rows. So, these are getting into more details, but basically it's like, let's say if you make a mistake while you're updating, deleting and stuff like that, you can recover essentially. So there are ways to recover from those deletions and stuff like that. Let's not go through all this. This one is important. I want you to understand this one. So often in SQL, you might want to create what are called temporary tables. And these are actually not temporary tables, which means that they don't physically exist, but they exist as a definition. And these are called views. So a view is a permanent definition of a result that you want to use as if that table exists. So create a view with patient and diagnosis information for all patients for a physician ID equals such. So this view can be created as, so the view is given a name first of all. The command goes something like this: create view, give it a name, the view name, as, now that generally it will follow a select clause after that, select command after that. So select PID, PName, PA.PID, pat name, date, decode, dname from the table physician, encounter, patient, diagnosis, encounter, diagnosis, where the join conditions. There are 5 tables. I would expect 4 join conditions. P.PID equals E.PID, E.PAT ID equals PA.PAT ID, and so on. And finally, a clause which says P.PID equals this particular value. I want this result only stored for this particular physician. So it stores all the encounters by joining multiple tables and creates a view with this definition. So which means any select clause, the output of a select clause can be stored creating a view. Correct? This command actually does not create a new table. However, if you want, someone asked me a question basically, can you store an actual table up from a view? Yes, you can do that. Okay, so create view, whatever, and then you can basically add at the end, add a clause which actually says, create this physical storage, and it will do that. But without that particular clause, create view just creates a view basically. So how is a view useful? Now let's look at that. Well, a view is very useful. So now you can see, I can use the view, even though I don't have a physical table, I can use the view as if it is a physical table. So I can simply say select start from pattern counter. And I can run any query on pattern counter that I want to. You have to remember one thing though, if you have not created a physical table, which you should not be creating arbitrarily because, because it requires space and a lot of administrative overhead. But what happens is when you are executing a view, remember, you have to remember some things that you can't, there is no indexing that is possible. Indexing is not possible if you don't have a physical table. So no indexing. Order by clauses generally cannot be used in views. Updates are restricted on views. No updates on virtual columns. Remember that virtual column was price times quantity. Those kinds of updates are not possible. No updates, insertions, or deletions on a view if the view is based on a join. So there are some restrictions on the views, unless you create a physical table, in which case there are no restrictions. But you can, like I said, without the explicit command to create a physical table, views can be just virtual tables. So this is how you create a view, and this is how you can use this particular table as if it exists by using this using a select command on the view. Any questions on this, on views?
Yes, sir. Sir, is there any query which we create by combining a view and an actual physical table?
Yes, we can do that. I think nothing stops you from using that. So for example, I could say select start from pat counter, comma, patient, and do whatever I want to do with it. Okay?
Yeah. Yes.
I have a question.
Yeah.
So if the tables have got some new records, does the view get automatically populated with those records, or
Good
does it get
question.
refreshed?
Good question. Okay, so if it's a view, basically, there is no physical table. So when you execute the view again, when you say select start from pattern counter, it will automatically basically give you the new records, right? Okay. Because there is no physical table, it will goes and computes it and then produces the result.
Okay, so real time it gets the data.
Yeah, in a view, it gets the data real time with an underlying computation that it has to perform, which is exactly this particular query, right?
Yeah, okay.
But if you store it as a physical table, that is, you store the result as a physical table, I don't know what really happens, because if it is being stored as a physical table, does it get dynamically updated? I'm pretty sure MySQL and these environments basically have clauses that you can add to add dynamic updates.
Okay.
But if you don't explicitly use that, you might be in trouble because the physical table may not be updated. So I can't answer that question, but you have to understand that there's a difference between the two environments that we talked about. One is just a definition of a view, which automatically will basically go to the underlying view definition to create the data. But if you have created a view and stored it as a physical database, I believe that you have to be a little bit more careful to see if updates will be reflected. My gut feeling is updates will be reflected because it doesn't make sense not to reflect it, but I don't know.
Okay, sure. Yeah, thank you.
Okay, any other questions? And actually, you can try it out. Create a view, and when you're done with the assignment, create a view, store it as a table, and change some data in the original table and see if it gets reflected in the view.
Yeah, I
That'd
think
be
that's
an interesting exercise to do. Once you know how to create a view, and the assignment actually asks you to create a view. So create a view, store it as a table, and see if it gets reflected. My gut feeling is it will be, because otherwise, you'll be in a lot of trouble, basically. But I don't know. I mean, I've never really tried it out myself. Okay, good. So moving along. I don't think this is really relevant at this point of time, but I just wanted to let you know that SQL also has security commands embedded in it, which can allow you to grant privileges on the database for doing different kinds of things. And those of you, and maybe you can see now when you actually are working in a database environment, why you can do only certain things and why you can't do certain things, right? And those underlying that are basically the grant commands that actually comes along with SQL. So these grant commands are, just to give you a few examples. So grant select on the billing table to Jones. Jones is a user ID. So now Jones can actually select records from the billing table. The only thing that Jones can do is basically select records, nothing else. No updates, deletes, modifications, or anything like that. Now, if you say grant select update on a view, remember that view that we created to Roth, then select and update will be available only on a subset of the records that you had created. So between view and grant, that combination, it almost allows you to basically control access to a single cell in one table, because you can create a view on that single cell and then grant access to that particular user on that single cell. So it's a very powerful combination, views and the security command grant. Grant all privileges on patient to user Duke with grant option. This is the most powerful, what you call a privilege that you can provide to someone. You basically say, okay, this particular user can do anything with that table, and including allowing others to get basically, it's like a cascaded grant, including others who can basically do exactly the same thing with that particular table. The database administrator can revoke any grants that have been, privileges that have been given. So revoke update on patient from Duke means basically the privilege that was granted earlier is being revoked. I just wanted you to know that basically that in relational databases, these grant commands are there, the view commands are there basically to allow you combinations of, it really controls security to a very granular level using these combinations. Any questions? One other important item, someone asked me basically, how do you get the structure of a table, right? So databases automatically create what are called catalogs and data dictionaries. Information regarding all the tables, all the databases, all the fields, everything that you've created, it has its own databases or own tables where all this information is stored. And those are called catalogs or data dictionaries. So for example, the system will store information regarding on all the tables, on all the attributes, on all the views, on all the indexes, on all the privileges, on all the users. And metadata basically is information regarding the fields and tables that you have actually used. So there is, when you're creating a table, when you're creating a view and an index and so on and so forth, the underlying that, the database management system will be creating catalogs to store all this information. Okay, and sorry, one other thing I wanted to say is that the catalogs themselves are tables. Okay, they themselves are relational tables. So if you knew the name of the table, for example, that has a stored table definition, you can query that table also. So if you knew the name of the attribute that attribute table that stores information regarding the attributes, you can query that data dictionary also. So that's kind of neat in relational database management systems, that catalogs and data dictionaries are also relational tables. And so you can query any of these things. In fact, that should probably answer the question that someone asked, basically, how do I get information regarding the table that I stored? If you know the catalog name where the table information is being stored, you can query that particular table to get that information. Okay, good. Now, so that's all the background that I wanted to give you on the data part of data analytics. And of course, we'll talk about, someone else will be talking about unstructured data and how we can move from relational databases into big data environments or generally unstructured environments. So for example, if I want to store pictures and videos, obviously this is not the way to do it. Right? So there have to be other ways of doing this kind of stuff. Now let's move on to another topic. Let's look at the analytics part. Let's look at the modeling part, okay, and see what's involved in there. So in order to do that, I'm going to open up another lecture. It's a lecture on data mining. Now, when I was actually talking about data analytics the other day, I did not use the term data mining. This is another term that used to be thrown around and it's still being used basically. Again, so what is data mining? Now, basically, now that you understand what data analytics is all about, can you explain to me, is data mining any different from what we have been seeing so far? And if it is, then tell me how.
Same.
Yeah, please go ahead.
You can say that data mining is an extension from data analytics.
Yeah, I mean, good. I mean, that's one way to look at it. But basically, data mining is another term for using statistics, AI, machine learning, and so on and so forth to mine the data, or essentially look at the data and interpret it in a manner that you want to interpret it. So again, I don't want to create a new terminology by saying that the application of these same models, and if you look at data mining models, they are the same models that we'll be talking about in data analytics. This is a terminology that was used about 10 years back, which has kind of evolved into the data analytics area. So some people will say, okay, we need to do data mining. Well, then you should probe into it further. How are you going to do data mining? And then you'll see that the underlying methods are again the same, statistics and machine learning and visualization and stuff like that. So then the question is data mining any different from data analytics as a broad field? No, not really. So I was actually going to change these slides to data analytics, but then I said, no, I'm not going to do it. I'm going to leave it like this so that you can see that what we will be talking about in data analytics, once upon a time, this used to be called data mining. And this is an old set of slides that I had. And at that time, I used to use the term data mining to talk about analytics. And you'll notice that what I talked about years back, and this was maybe 5-10 years back, is still relevant today as to what you're going to be learning today in this particular, not today, but in the next few months in this particular program. So I kept the slides exactly the way it is, but use it interchangeably. Just call it data analytics, or whatever you want to call it. Again, don't get bogged down by the terminology, or data science for that matter. So I've had problems with the term data scientist. I'll give you an example. Someone basically said that I'm a data scientist. I said, great. Can you basically do machine learning and AI, module for me for this particular program? And the person said no. And I said, why can't you do it? He said, basically, I'm a statistician. So you see the thing, the terminology data science can be used so loosely, and the terminology data mining can be used so loosely that you don't know exactly what is underlying that particular terminology. If once you've gone through a program like this, you should be able to probe deeper into it and not just get bogged down by the terminology data science. The question is, or data mining, question is, can I interpret the data using the available gamut of algorithms and procedures that I have that can range from statistics all the way into AI? So I wouldn't want you to focus on who's a data scientist or who's a data miner, who's an AI guy or who's a machine learning guy and stuff like that. I don't think any of that matters. But at the end of the day, do you have the tools and technologies to be able to analyze the data? And those tools and technologies, like I was telling you, comes from all different domains. Like you saw today what we were doing with SQL. SQL is an old language, right? But even with SQL, I can do a lot of data mining without even needing, what do you call, very sophisticated algorithms. I can do basic, computations, aggregation of data using just SQL. And that too from very large databases. So don't focus on the terminology. Now you're going to focus on the methods and procedures used in this broad area called analytics, okay? So what is data mining? Discovers hidden patterns, relationships in the data. You can forecast based on the data. You can characterize and explain behavior in the data. Primarily a descendant of statistics, but now with the expansion into data analytics, machine learning and AI and statistics cannot be what you call, they have to be looked at in conjunction to each other. And I will show you today, actually, that the basis of machine learning is also AI. Is also statistics. Okay, so if you look at the continuum from statistics to AI, it's actually a continuum, basically. You can't say that, okay, statistics stops over here and data mining and AI starts over here. There are the interplays between the two areas. Very hard to distinguish one from the other at certain points of time. When you're using basic regression and all that, yes, I can say it's a simple statistical model, and this got nothing to do with AI as such. But when you use the word machine learning, is regression basically a machine learning algorithm? Some people would argue, yes, it is. But I don't want to get into those kinds of arguments, basically. I just simply want to tell you the continuum that exists in these analytical models that we are going to be focusing on in this particular program. So data mining, data analytics can be used for all kinds of things. Suppose customers are leaving from your company. Can I basically get a pattern of who these customers are? Why are they leaving? Can we now take action to prevent these customers from leaving? Example that when you mine the data and you go into the data, you find that customers from a certain region are leaving. Right? So for example, just to know this, you don't really have to have a very sophisticated algorithm. You can simply basically run a select query on your database, get the number of customers for a given region by date, by year, and that will actually show you the trend. You see that? So the algorithm or the procedure that you use to mine the data or go into the data depends upon the answer that you're trying to get, but it depends upon the question that you're essentially raising. So are there higher prices in the region? This customer service in the region is deteriorating? I don't know. So that's where analyzing the data will help. Why do we need data mining? Obvious. We need it for competitive advantage, increasing revenues, reducing costs, medical diagnostic aids, fraud detection, financial prediction, all kinds of stuff. Advertising, marketing, there's no end to it. Example applications of data mining, retail applications. What are good demographics for store like location? Should hammers be close to nails in a store like a Home Depot? What products to stock, how many and when? In the financial area, what characteristics do fraudulent claims have? Is this an unusual credit charge? Is this loan applicant a good credit risk? Portfolio risk management. In manufacturing, which tire should be tested or which component should be tested? What circumstances lead to reduced output? When is intervention required to stay within pollution guidelines? All kinds of stuff can be asked. All kinds of questions can be answered using, analytics of the data. In in the medical domain, who are poor candidates for angioplasty? Who should be tested further for hypertension? Who are more likely to have colon cancer? All kinds of questions can be answered, provided you have sufficient data. So for example, someone asked me the question the other day, how much data do I need? If you have data like for 100 colon cancer cases, I'm not so sure that you'll be able to make conclusions based on that. But so, again, the volume of data will also tell you if at all there is a pattern, underlying pattern that you can distinguish. So the whole idea is, can we figure out underlying patterns in the data? In the insurance industry, predict likely levels of claims, which claims should be investigated, what are the characteristics of profitable agents, and so on. So all kinds of questions can be answered with, or it can be looked into. I'm sorry, I shouldn't be using the word answered. Can be looked into using data analytics. So now I'm going to give you examples of certain data analytics models that we use in a program like this. And I'm obviously going to not spend a whole lot of time on each of these models, because this is the purpose of this particular program. Each of your modules, as we'll see in the next few weeks, will be focusing on each of these modules in more detail. Okay, but what I'm trying to do is to introduce you to the data analytics area at the highest level possible, okay, without getting too much into the technology and to the science behind it. But I think the understanding of data analytics from a very high level is going to help you as you progress in this particular program. And it will also help people who have not been technologists or have not been IT guys, or have not been statisticians, or have not been into computer science, or whatever the case might be. I think it creates a level playing field for all of you by looking at it from a higher level. So what I did in the yesterday's class and today's class in the databases area is to make a level playing field for all of you. So now you know what relational databases are, even if you have never really worked with databases. Now you know basically what tables are. Now you know how to query a database. Now you know what a query language is. Now you know basically what, how to create databases, how to, and of course you have learned a few nuances also. Now you know how to do joins and stuff like that. So even though I started from the basics, I went quite deep into some of those areas so that, I think all of you have a reasonably level playing field, but irrespective of your background. And I'm going to try to do the same thing on the modeling part, so that all of you come from different backgrounds, but with this quick review, and I'll do it in a very simplistic style so that, there's nothing that I'm going to use over here that's going to be a lot of jargon. Okay, so what is the purpose of analytics? The purpose of analytics is basically, I've got data and I have a problem, and I want to see, using the data, can I address this particular problem? And how do I try to address it? By saying, okay, there are analytical tools that are available to me that will allow me to capture hidden patterns that may not be obvious from just looking at the data. That's the purpose of essentially using analytical models in this environment. Right? All of you are with me on that? So there are, of course, hundreds and thousands of models that can be used to analyze data. But we can't look at all the models, right? So what we will look at is certain set of models that can be readily usable by you to do some basic analytics for given data sets. So connecting the data set to what we just did you notice that the most readily available data set will be in the form of a table, right? Remember, we were talking about transaction systems. Transaction databases are basically tabular databases. So which means, they are relational tables. So they'll be essentially rows and columns. Interestingly, a lot of the analytical models also expect rows and columns to be able to analyze them. And one of which is regression models. So in a regression model, we basically, and regression obviously comes from statistics, okay? And so what we assume over here is that we are trying to map a data set that has something called a predicted variable and something called a predictor variable. So something that I'm trying to predict and something basically that will help me predict. So let us take an example. Suppose you remember basically the hospital database that we just talked about, the encounter table and so on. Suppose we have an encounter table that has information regarding the billing that has taken place from different regions in the hospital. And let's say this is a massive hospital that is, basically in multiple regions across the country. And what I want to do is I want to be able to predict basically what the sales will be for this, large conglomerate hospital in the next quarter or in the next month or whatever time period you choose, based on certain independent variables that will allow me to predict sales. So one of the columns in the regression in this particular table is essentially sales information. That is the total amount invoiced against all the procedures that have been done by a doctor. So that is called Y. Basically, that is the Y variable. What we are trying to do is to predict the sales, right? So this one, so this one is the dependent variable or the predicted variable that we are trying to predict. And let's say in this particular example, it's sales. Now in the region, basically, we have certain predictors of that. For example, one of the predictors might be the month. Another predictor might be basically the month on which the billing occurred. Another predictor might be the type of disease, basically. So let's say it's the diagnosis code. Another predictor might be, let's say, the zip code. Certain zip codes basically have a relationship between the sales or the total invoices and these parameters. So, of course, you could have a lot of independent parameters connecting Y, the dependent variable, to X's. Okay. So in this particular model, what we are trying to do is the following. So we've got Y, the dependent variable, and X is the independent variable that is trying to predict Y. So if I plot what is called a scatter plot of the data that relates, let's say, the month to the sales, and let's say X's are basically months. So this is, say, January, this is February, and so on and so forth. And I've got all these data points that show up on this. One way to essentially see if there is a relationship between Y and X, you can just look at the data points, and if the data points are scattered like this is also called a scatter plot. You can see that there is an implicit linear relationship. Okay. In linear regression, which is what we are looking at, essentially, what you're trying to do is to best fit a line that fits into this data set of Y's and X's. Now, if it's basically not just x1, but x1 and x2, then we are trying to best fit a plane. And if it's x1, x2, x3, then it's basically a multidimensional or a hyperplane that we are trying to fit into the data. But in any regression model, whether it's linear regression, multiple regression, whatever the case might be, we are trying to fit in what is called a best fit model. Are you all with me so far? So how do I know it's the best fit? Is this line the best fit, or is this line the best fit? Or is it this line the best fit? How do I know what is the best fit model? In machine learning, starting with regression, you always have something called a cost function that you're trying to minimize. And in this particular case, the cost function is the error function. And the error function is nothing but basically the actual value of the data, which is this point, and the predicted value, which is this point on this line. So yi hat is called the predicted value, and this is the actual value. The difference between the two is called the error. We normally magnify the error by squaring it, and then we try to minimize the error term by basically taking the partial derivative. And again, I don't want to go into calculus and stuff like that, by taking the partial derivative of this error term with respect to the different x's basically that we have. If you solve that equation, basically, you will get equations for basically what are called the coefficients of the linear function that maps this data. And remember, this particular line will have it'll have a linear function called C0 plus C1 times X. I can't write. So basically, a linear function is simply y equals C0 plus C1x, or y equals B0. So this is an example of a linear function. So this is A, which is the intercept, and this is really the slope and the independent variable. So what you will be getting is y equals C0 plus C1x, or y equals A plus B1x. So the purpose of creating a regression model is to identify a linear equation that relates y to the x's. And once you get the best fit linear equation, then you can use that linear equation to predict future values. So for example, now if let's say I have something called y equals 2 plus 3x. Then what I can do is, and if I know the value of x, then I can just simply substitute the value of x and get an estimate of y. So that's all that linear regression actually does. Any questions on linear regression, basically, or linear equations that try to map a data set? If you understand this, most of machine learning, whether it's neural networks or deep learning or whatever the case might be, they're all trying to do this in different hyperparameter environments. So
hello,
yes, sorry, go ahead. Yeah.
Hello, sir. Dharmendra here. I have some few questions on this regression model.
Sure.
Sir, basically, we talked about this predictor variable like month of billing, type of disease, and all. So that was like 3 or 4 parameters that we already know. Say, for example, if you have some 1,000 parameters, is there any mechanism to choose which one will actually affect the predicted variable?
Yes, definitely, yes. I mean, you have to be able to do that. So what people try to do is this. They throw in the 1,000 parameters into the model and hope for the best, right? And I will also show you that the more the number of parameters that you throw into the model, the better the fit will be for that particular data set. That means you will be able to predict, or not predict, you will be able to map y to the 1000 x1, x2, x3, 1000 variables. And suppose you had, a 1 million rows of data. Coming up with a mathematical model that represents y is a function of those 1000 variables is a relatively easy task, provided you have computational capability. Okay, and I'll demonstrate that to you. It's a very, very easy task. But you take that model, y equals a function of those 1000 variables, and you take it out of sample. That means you try to predict something that's going to happen in the future. It's going to fail miserably. Okay, and I'll explain that to you. And that goes back to your question. Actually, what you want is the simplest model with the least amount of noise. So which means if you can predict y using 3 out of the 1000 variables, you're much better off for future prediction than using the 1000 variables. Because a lot of the 1000 variables is pure noise, and it actually what is called overfitting the data, and it produces models that are completely useless. So coming back to your question, yes, one of the primary exercises in data analytics is to come up with the simplest model that maps the data best for prediction purposes, not the most complicated model. The more complicated the model is, and actually I'll now give you an example why that doesn't work. So suppose the data points were like this.
I have a basic doubt. This alpha and beta, what you mentioned, it's actually is error coefficient or line equation coefficient?
It's a line equation coefficient. It's basically alpha is A and beta is B1. Okay.
But, in the first one, we have chosen with A plus B1x plus B2. So we need to get 1, 2, 3, 4 parameters, right? So I'm getting confused with that. Why we alpha and beta has come? Actually, it is not a line model, right? What you're written in the top.
Yeah, actually, let's you're right. I mean, basically, I just use alpha and beta, but in general, this should be. I'll tell you what it should be. It should be beta 0, which is A, and the coefficients beta 1, beta 2, beta 3, up to, beta sub n, depending upon the number of parameters you have to predict y. Does that make sense? So in this particular case, the equation will be, the regression equation will be y is equal to beta 0 plus beta 1x1 plus beta 2x2 plus beta 3x3. Does that answer your question? Or maybe you have had a different question. I didn't quite understand.
Correct only, sir. I got alpha, beta, and then x1, x2. I just confused with that.
Yeah. I'm sorry to confuse you. Just ignore these. Just go with beta 0. I mean, generally, we should use just beta 0, beta 1, beta 2, beta 3, up to beta sub n. Just ignore this, please. Okay. So to generalize that, use just beta 0, beta 1, beta 2, beta 3, up to beta sub n.
So the linear regressions can be used for any dimensional approach, right?
Yes, you can use multiple dimensions. That's not a problem. And as you go through the course, you will see that we will actually not only have linear equations, but we'll have polynomial equations also. So for example, this is an example of a polynomial equation, right? So I can have y equals beta 0 plus beta 1 x1 plus beta 2, beta 1 x1 plus beta 2 x1 squared. It's a quadratic equation. So linear regression model simply says the model is linear, but if you have a polynomial regression model, I could basically have nth order polynomials trying to map the data. So mapping the data is not a problem. I can come up with any mathematical model and map the data. So Going back to that example that I was giving you, so suppose the data points were like this. If I had a fairly sophisticated polynomial equation, high-level polynomial equation, I can map that fit the data perfectly. Right? But that's not the objective. The objective is to come up with the simplest model that fits the data with the least amount of error. Are all of you with me on this?
Yes, sir. Sir, I have one more question.
Sure, please, go ahead.
Sir, taking the same example of this hospital case, say for example, hospital was started before some 6 months back, and we have data of 6 months, and they're predicting the sales of the 7th month based on the month of billing and all. And at this time, might be the temperature of the region might not be having a greater effect. Just for example, might be the next year when we actually see the temperature, we are seeing that there is a close relation between the temperature and sales. And when we analyze that, we are coming to know that the temperature is affecting some cold or cough cases, and which is increasing this the sales volume and all. So in the same way, when we actually have lot of time, I mean the data is getting collected over time, might be some insignificant parameters might become significant, right, sir? So is it required to run this rule periodically to understand the closest model and then update the model periodically?
Yes, I mean, of course, models should be updated periodically. There's no doubt about that. But what you just said, I wouldn't run the regression model with temperature, because if you've got 6 months data and you're trying to predict basically what's going to happen on the 7th or the 8th month using temperature, you don't have complete data to even predict what's going to happen in the 7th and 8th month. So definitely temperature should not be one of the parameters in that model, because it's going to give you because there's nothing for the system to learn from, right? Do you see what I'm saying?
Yeah, exactly. So might be the next year when we actually see that the temperature is having effect, because we have run 2 seasons, and these 2 seasons have actually got some relation. Might be that time the data might become right.
Yes, right. And in fact, I won't even just depend upon 2 seasons. I would, in order to really make a proper prediction, basically, I would probably have at least 5 or 10 seasons, because last year the weather might have been abnormal, right? So you have to be very careful about, like I'm saying, you can always come up with a model that does well on the sample that you have. But when you take it out of sample, it fails. So you have to use human intuition basically at the end of the day to see whether the parameters that you've selected make sense or not.
Okay, sir. Sir, actually, this is my exact question. You told about taking some 4 or 5 seasons and then taking that parameters into consideration, right, sir? So that 4 or 5 seasons is actually giving us some kind of confidence, telling that this is closely linked with the predicted variable. So what is that number? How to derive that number is my question, sir. Say, for example, you have 85% of confidence telling that this parameter will actually affect the predictor parameter or something like that is there for us mathematically to...
Yeah, for example, in statistics, basically, if you can say with confidence that there is a 95% confidence that I have that Y is affected by X1, then I will be willing to take that X1 variable into consideration. If the confidence level is 60 or 70%, no, I wouldn't take it. Basically, it says that it's just noise. So the level of acceptance is pretty high. I mean, to determine whether X1 impacts Y, I would actually, in statistics at least, we at least look for a 95% confidence level.
Got it, sir. So this will be the basic rule for us to add the particular parameter to the already existing model, right, sir?
Yes. If you find that, there's something called a p-value. If you that tells you the level of confidence. If the p-value is like very low, and it's very and actually the model will tell you whether it's significant or not. If it's not significant, drop that variable, because it essentially shows us that it's not going to impact Y. So why have it in the model? It's just create noise, basically.
Okay, thanks a lot, sir. That p-value was a new term for me, and let me also read through it, sir.
Yeah, actually, if you run a regression model, you will get basically something called the F statistic, and also you'll get something called the p-value. You'll see that will be the last column on the thing. That p-value is very important to indicate which independent variables are significant and which ones are not. So when you do statistics in the next class, basically, you will see some of that. Basically, one of the things that you'll understand how to do is to understand the result of a regression model, how to interpret that particular table.
Correct, sir. Thanks a lot.
Okay, good. So now let's move on. There are certain assumptions that regression will have. It's a linear model. There should be a normality assumption, and it works best for continuous variables. If you have classification variables, you'll have to do things with it. All that will be covered as we move along to the next topics. But that's not really what I want to focus on over here. I just want to give you a sense of what is it that you'll be seeing in the next few months. Forecasting, as contrasted to regression, basically is autonomous. In a sense, you use past data to forecast the future. If the past data of sales is indicative of the future, it will work. But in most cases, actually, it's not a very good indicator. It's just really basically indicating a trend. So forecasting is important, but it's important to know what forecasting is all about. But I don't know whether forecasting is going to take you too far. Okay. And basically, what it identifies are called univariate patterns. Now you notice, now we'll go into another kind of predictive algorithm, broadly classified as decision trees. Okay, so what are decision trees? So now instead of trying to come up with a mathematical function, we're going to use an algorithmic function basically, which tells me how to classify the data. So decision trees are iterative splitting. Now, decision trees, again, is really at the cusp of AI and statistics. Regression was primarily statistics. Oh, incidentally, I forgot to mention one thing over here. Let me just go back to this. This is called a closed form solution of the regression equation. When you have 1,000 variables or 5 variables or 10 variables and so on and so forth, often there is no mathematical equation that can be found out basically to come up with the beta zeros and beta ones and beta twos and so on and so forth. So you have to use what are called algorithmic approaches to come up with the solution for beta 0, beta 1, beta 2, beta 3. And one of those solutions is called gradient descent algorithm. Okay, and that's not a closed form function what I mean by that is that's not just a formula that will give you the values of beta 0, beta 1, beta 2. You'll have to use an iterative algorithm to come up with the values of beta 0, beta 1, beta 2, beta 3. That will again be discussed when you're doing machine learning, and then you'll see that regression actually feeds into machine learning because there are certain solutions that are not possible to get from statistics. In using when you're even dealing with regression, you have to use concepts from other areas, and gradient descent is basically somewhere in the middle of machine learning, AI, and statistics.
Sir, I have a doubt actually. Okay.
Yes, yeah.
Now in this present one, X1, B1 and B2, beta 1 and beta 2 are the results what we are expecting. Okay, from this regression model. What will happen? Consider B1 X1. Okay, X1 is an input. Okay, X1 is a actually maybe an output of other functions also. For example, X1 is an input to this particular regression model, but that was an output from some other data, and then it is come to here. So which is having a different trend altogether. So in this case, regression models will work, or simple regression models will work.
No, actually it won't. So let me give you an example. So suppose X1 is computed from X2 and X3. So X1 is equal to 2X1 plus, X1 is equal to 2X2 plus 3X3, let's say. I'm just as a simple example. So it's computed from X2 and X3. If you put X1, X2, and X3 in the model, regression doesn't actually work. This kind of a problem is called multicollinearity, and when there is multicollinearity in the data set, regression actually does not work very well. So yes, when you put in these variables X1, X2, X3, make sure that they are independent of each other. And one way to see that is something called a correlation matrix, which I think will be talked about in the next few classes. You run a correlation matrix to see if the x1, x2, x3s are independent of each other. If there is a correlation between x1 and x2, drop one of the variables. Okay, does that answer your question?
Yes, sir.
Okay. So decision trees, it's an iterative process of splitting of the data into groups. The goal is to maximize the distance between the groups so that you can get distinct groups. And the idea is to determine the best split possible. Okay, so I'll give you a very simple example of how the logic works basically. So suppose you have a credit risk example. So suppose I've got 5 loan applicants to a bank, and let's assume that the data set has, from past history, 2 of those data sets are good cases and 3 of them are poor risks. So that means poor cases, that in the past basically they have failed, that they have not paid back to the bank. So, and let's assume that the independent variables to assess risk is income, and income is, let's say, just classified as high and low, whether the person is married or not, yes or no, and whether the person has high debt or low debt. And the dependent variables are risk, which is good and poor. Okay. When I draw the data points on, of course, taking 2 variables at a time, okay. So if I plot married yes or no and plot income low and high, okay, I get the points, basically the poor risks as over here. This is a poor risk, and this is a good risk, and this is a good risk. Okay, actually the splits are wrong basically. Just one second. Yeah, these values got shifted. So this is actually a G. Okay, and I think this is also a G, if I'm not mistaken. I don't know what happened to these values. They got shifted, and the splits that are shown are incorrect, basically. So I mean, I can't tell you exactly what the original split was, but let's assume that the original split was like this, that these 2 were good risks. That means when the person was married and the income was high, we found that they were good risks. When the person was not married and income was low, they were a poor risk. And we also found that when the person is not married, they were actually poor risks. Okay. So what the algorithm actually tries to do is to go through the data set and find splits that will allow it to create a decision tree, which basically is in the form of if then else type rules. So here is an example of that. What this is saying is that if so again, this has all got distorted. Just one second, let me recreate this. Income is So if income was low, we found that the two cases that we had, they were basically poor risks. Okay, so then we can simply say from the data set that if income is low, then the two cases that we have, they were both poor risks. And essentially when income was low, there were no good risks. That means basically that it's going to be a credit default. When income is high, okay, we found two good risks and one poor risk. So we need to basically split this up further, okay? And we now say when this is not right. When merit is equal to yes and income is high, then both are two good cases. And if merit is equal to no, and even though income is high, then basically that is a poor risk. So this is actually 0G, and 1P. I will actually correct this diagram and make sure that it is shown correctly. So at the end of the day, the decision tree basically tells me based on those 5 cases, of course, it's a very simplistic scenario. If the income of the person is low, then it's a poor risk. If the income of the person is high, then basically we don't yet know whether 2/3 of the cases are good risks and 1/3 of the cases is a poor risk. If the income is high and the person is married, then 100% of the cases are good risks. If the income is high and essentially and if merit is equal to no, then they are all poor risks. So in this particular decision tree, I've come up with a set of rules based on the data, classification data that I essentially got. So algorithms and decision trees, which you'll again be learning in the context of the next few months, is a very different way of coming up with prediction, basically. What we do over here is create a tree where each branch will take me to a certain outcome. Now, one thing you notice is basically in these branches, the outcome probabilities all are 100%, right? Based on the data set. But in reality, you will never have that situation. You will have probably 97 cases good and 3 cases bad. So then the question is, do I stop creating the decision tree at that point of time, or should I continue to do it and basically make sure that the outcome is 100% true? So when you're building decision trees, that is called basically a threshold at which you want to stop. It's similar to that confidence level that someone was asking me recently about, okay? So when you create a decision tree, one of the associated parameters that you will have is the confidence level of the rule that you have created. Any questions on that? Because that part is kind of important to understand. Now, again, all these will be repeated in much more detail when you get to it, but I just wanted to give you a basic sense of how decision trees are contrasted to regression, for example. Any questions? Okay. So, and then I've just gone through the rules. If income equals low, then risk equals poor. Income is high and merit equals no, then risk equals poor. So that the confidence in rules determine the efficiency of the rules. I just talked about that. Suppose you have 97% confidence. That means, suppose you said 97% to this, then what I'm saying is that the model is saying if income is low, then risk equals poor. This is true 97% of the time. But suppose this was true only 50% of the time, the second rule. Do I have confidence in this rule? Probably not. That means 50% of the time I'm going to be wrong. Okay, so the confidence level will matter basically in terms of how good or bad the decision tree is. So the advantage of trees over regression is it provides explanatory capability. The disadvantage is that overfitting can be a problem. Okay, and overfitting is a problem in all these cases. So we'll talk about that shortly. Of course, these rules can be much more complicated. So for example, if national income divided by total assets is equal to quartile 1 of this ratio, then and current assets and total divided by total assets of quartile, one of this ratio, then bankruptcy is equal to 97%, and not bankruptcy is equal to 9.3%. So these rules can get a lot more complicated than the simple examples that I've given you. It depends upon the nature of the problem. Okay. So another form of regression is called logistic regression. Logistic regression is a nonlinear form of regression, and it primarily basically computes the output is just a classification variable, y equals 0 or 1. What that means is, suppose I want to predict whether a company is going to go bankrupt or not. So yes or no, so essentially it tries to give me yes or no answers. It has some similarity with linear regression. If you look at one of the equations, it's basically of the form y equals b0 plus b1 x1 plus b2 x2 plus b3 x3 and so on and so forth. But it's got a nonlinear form. What it does is it takes this y equals b0 plus b1 x1 plus b2 to x2 and so on and so forth, and converts that into a sigmoid function using this particular equation. It's called 1 over 1 plus e to the power of minus y, this whole thing. Okay, and this function looks like this. It varies between 0 and 1, and it's called a sigmoid. So that means the minimum value is 0, the max value is 1. So if you notice, this is called the logit function. Basically, it can take a linear regression like this and convert that into a probability of y equals 0 or y equals 1. So logistic regression can be used for categorical variables, not continuous variables. So for example, y is 0 and 1, and x1s are basically continuous variables. x1, x2, x3 are continuous variables. Again, this will be done in more detail, but there is a reason why I introduced logistic regression out here. I just want you to understand something. You have a linear equation like b0, b1, x1, and so on and so forth, and I can convert that linearity into nonlinearity by using this equation called a sigmoid function by taking 1 divided by 1 plus e to the power of this particular linear regression output. Are all of you with me on that conversion, basically? Because when I convert it into a 0 or 1, it basically is like a probability. Probabilities, as you know, ranges from 0 and 1. 0 to 1, right? I just want you to understand that part, not the mathematics behind it. That I can take a regression equation, convert that into a value 0 to 1 to classify an output variable, which will be essentially 0 and 1, which could be bankruptcy, yes or no, as an example. Any questions on that? Okay, how am I going to use this? Here's how I'm going to use this. So now I get into what is called, now we're completely into the machine learning environment. So this was still statistics. Now you see I'm making a transition towards machine learning. So now what I'm saying is, okay, let's say we have a y that I'm trying to predict. Let's assume it's a classification variable. And we have 4 independent variables, x1, x2, x3, x4. Regression is y1 is equal to b0 plus b1 x1 plus b2 x3 plus b3 x3 plus b4 x4. All of you understand that part? And again, another regression equation where basically I can do a linear regression, y equals x1 b0 plus x1, b0 x1 plus, sorry, b1 x plus x1 plus b2 x2 plus b3 x3 plus b4 x4. Now let's say I do something interesting. I'm saying now I'm going to introduce nonlinearity in the model. I'm going to now say that y1 is actually not equal to just b0 plus b1x1 plus b2x2 plus b3x4. I'm going to convert that using a logistic regression function. Remember the one that I just showed you in the previous slide. I'm going to take that value and convert it into 1 over 1 plus e to the power of minus the regression equation. So now you notice y1 and y2 at this level basically is a sigmoid function. It's a nonlinear function. And then I use those outputs into the next layer, and I use W1, W2, or a new sets of beta 1, beta 2, and then compute another y hat and convert that y hat to, again using a sigmoid function, into another value. So what am I doing over here? I'm creating some arbitrary independent variables in these layers that I'm creating arbitrarily at the input layer. And I can actually create as many arbitrary intermediate variables. I can create as many layers as I want to in this neural network. It's called a neural network. Nothing prevents, because those are fictional independent variables that I'm creating. And I'm creating it in multiple layers, not just 2 layers like this. I could extend it to multiple layers. So now you notice something. When I look at the final y calculated from these x1s, x2, x3s, x4s, going through all these intermediate layers to this y computation, it's now a very complex mathematical function, right? So the intuition behind neural networks is, if I can actually map any given data set, x1, x2, x3, x4, up to x1000, by creating multiple hidden layers and multiple what you call output layers, not multiple output layers are only one, but multiple intermediate layers, to come up with a very complex mathematical function. And intuitively, you can see that any y can be mapped to any set of x's without any, if I have no constraints on the number of hidden layers and the number of intermediate variables that I create. So neural networks has the capability of mapping any data set. Doesn't matter what the data set is. And it does it using an iterative approach. Now, I did not explain the iterative approach. The iterative approach is, we start with a certain set of weights, or beta zeros as we call it, beta 1, beta 2, beta 3. But then we keep changing those weights in an iterative fashion by minimizing the error function every time. Basically, we do what is called a backpropagation. So we minimize the error function like we did in regression. If you remember that error function minimization, it can be done at each of these levels in neural networks also. So we keep changing the weights key, we keep changing the weights key, we keep changing the weights until basically we find an exact fit of the data. So you notice you quickly move from something that you understood very clearly here, simple regression. When we went to decision trees, very simple set of rules. But now we are getting into an environment where for humans, it's impossible to understand what the heck is going on over here. Because now we are entirely dependent upon a computer to do the mapping between y's and x1s. We are only telling it basically that this is the set of inputs we are going to give you. We will essentially create as many hidden layers as possible. I will give you the input x1, x2, x3, x4. I'll give you the output y. I will give you an initial set of weights, but now I'm going to let loose, and you decide what the mapping of y to x's will be. So that is truly called machine learning, because now we are expecting the machine to tell us what is the mapping between the y's and x1, x2, x3, x4. We have no formula by which to compute this. Okay, do you understand the intuition behind machine learning as compared to statistical models? And that's why I was trying to tell you that the whole thing lies between a spectrum between where machine learning basically takes over and where statistics basically, ends. So I can't tell you where statistics actually ends and where machine learning actually takes over, because statistics is embedded in machine learning all the time. Okay, any questions? I'm sure you have questions, so let me see what kind of questions you have.
Sir, I had a question on this neural network. So what it looks like is that the parameters can be many, and there can be on the outset of the question there might be the parameter might not be related to the solution that we are looking at. I mean, is that when this is used? Like I mean, what I mean to say is that, for example, you are measuring whether tomorrow it will rain or not, and then today you are checking something totally different, like you are maybe looking at the number of buildings in the area, or maybe something of that sort.
Good question. So suppose you want to predict whether tomorrow is going to rain or not. Okay. I find that generally when it's cloudy and the humidity level at a certain point, basically it drains, and 99% of the time it drains whenever it's cloudy and when the humidity level is at a certain point. If the model is as simple as that, then using a neural network is actually overkill, because I can do that using a simple regression model, right? But now let me give you another scenario, face recognition. Suppose you want to recognize my face or anyone's face. How do we recognize a face, or how does a computer actually recognize a face? Let's see how a computer could do it. One way to do it is basically called pixel matching, or how to match pixels. So the face can be broken up into a grid of pixels. Of course, I can't draw over here, but you can see the intuition behind it. The number of pixels is basically could be 1,000 by 1,000, right? And then here is a face in here. So if it is a black and white face or a color face, doesn't really matter basically. When you look at each of these pixels, if you have 1,000 by 1,000 pixels, each of these pixels will have a shade. And let's say the shade can be given using a number between 1 and 256. So now I have in order to capture a face, I've got 1,000 by 1,000 what you call array, or 1,000 by 1,000 table with pixels basically, which tells me the shading for that particular face using a number from 1 to 256 or 0 to 256. Now, let's say I ask the model. So now the model can learn it in lots of different ways. I can learn it using neural networks. It can learn it using regression. It can learn it using decision trees. It can learn it using different kinds of models, right? So let's take a very simplistic view. Suppose I give it another face of the same face, basically, using a same grid and using the same pixel values. It's simple to say that this face belongs to Tarun Sen because the pixel values in that 1,000 by 1,000 array matches the pixel values that has been provided by this input data. Okay, are you all there with me?
Yes, sir.
But now suppose I introduce a lot of noise in this data. Now this time Tarun Sen's face is not as clear as this original face. Now it's a side view, and the pixel diagrams, basically the pixel images between the two don't match. Now you notice the same problem has become a lot more complicated. Now the question is whether regression is going to work. Probably not. And even neural networks may not work over here, even if you have a very complicated model over here, because now essentially I've even changed the view of this particular guy. I've essentially now have a side view. I mean, here I had a frontal view. Right? So now, apart from using a complex model, that might not solve my problem. Actually, what might solve my problem is to look at it much more simplistically. I do not store pixels to store that face. What I do is basically I measure distances. So I measure the distance from the mouth to the lip, I measure the distance between the center of the eye, eye to the center of this eye. I measure the distance from the ear to the nose, all kinds of stuff. Actually, if you look at facial recognition, it is doing more of that than basically using pixels or images. So now I have a better set of parameters to predict a face that is not as noisy as basically, just using pixel images. But even then, the variation might be quite a bit. And using simple linear regression or nonlinear regression may not work. Here, I might try a neural network to see basically it works. And if it works, great. If it doesn't work, then frankly, I'm out of luck. Now I can try multi-layered, but see, the problem is, this problem is so unstructured that I don't know what the parameters will be. I mean, using y and x's directly, using a regression model or a nonlinear regression or polynomial regression model may or may not work, and it's probably not going to work. So I need a more complex model that I don't know what it is, but let me see if I can throw a neural network at it and whether it can learn. And if it learns, great. If it doesn't, then sorry, I'm out of luck. But we know that it learns because facial recognition is pretty common nowadays, and it actually does a pretty good job. Does that answer your questions?
Yes, sir.
Okay, so one quick thing that I want to talk about before basically I close this class. This part is very, very important, and I was hoping to convey this message to you. Getting a model for a data set is not the problem. Because, as I showed you using neural networks, any kind of data set can be mapped as long as you have the computing capacity to do it. So what do we do basically? What we normally do is we take, suppose you have 1,000 lines of data from which to learn. What we normally would do is we will use 200 of those as a holdout sample or a test sample as we call it. And we learn from the 800 samples. So we run the neural network or the regression model or the decision tree algorithm, whatever it is, on the 800 data set. And when we know that it has learned well by using a stopping parameter, then we test it out on the holdout sample and see whether it has learned. Because the holdout sample is something that it hasn't seen. And see if it has learned. If it has learned, great. Then we go out and change, then we go back to the learning sample and so on and so forth. If we keep training this model using the training data, it'll keep on it'll essentially keep on learning basically. So sorry, again, this thing has got an offset. This is the training data and this is the holdout sample data. So the top one is the training data. It'll keep learning until it basically perfects that data set. And it'll get to close to 100%. But I don't want that model. I want the model where it shows in the training data, it keeps on learning, but at some point of time, the learning becomes worse. So at the point at which it starts deteriorating performance, that's where I want to stop my training. So I want an approximate model rather than an exact model, because the exact model is not very good.
What if we have different peaks instead of just one peak?
Can you repeat that question, please? What is it? Can you repeat that, please?
Yeah, so in the test data that you're showing here, the dotted line, we have just one peak, right?
Just one what?
One peak value.
Oh, one peak.
Yeah. So what if we continue to increase the number of cycles, and if we have multiple peaks, how do we determine when to restore?
One would expect that basically there won't be multiple peaks and it will keep deteriorating. But suppose that has multiple peaks like this.
Mm-hmm.
If it was me, I would essentially stop over here and not have any more, not go any further. Because remember, the objective is to come up with the simplest model and not the most complicated model. The more you make it learn, the more it learns noise in the data, which is not good for unstructured tasks.
Sir, why is it so like moving to perfection is not desired here?
So here, so go back to that face example that I was telling you basically. If you move to perfection, which you can easily on this one, If the new face that it comes up with is exactly this, I'm really home free, right? But if the new face is an approximation of this, then I'm better off if this model itself was an approximation. The error on the holdout sample would be lower. The error on the training sample will be close to zero, but the error on the holdout sample, the total error computed for different samples will be lower. So that is why an approximation is generally better than coming up with the exact this thing. But if you did provide me with a situation where it's going to be exactly the same, the input, then of course you're right. That basically, the precise, what you call model works better. But I can't, think of too many scenarios where, like an image, basically you would have problems. Voice might be, voice recognition might be a little better because, voices don't change a whole lot. So maybe in that scenario, it might be good. Character recognition also, the word L can be written in so many different ways. Like it can be written like this, someone might write it like this, someone might write it like this. So there are so many ways of writing it that approximations are better than basically having exact. Now, approximations also have a problem, basically. Suppose someone wrote an I and the dot was very, very light and it didn't show up. Then, of course, this I could be thought of as this. And of course, you can see the kind of junk your character recognition problems, basically, when you're using Apple or when you're using word corrections, basically on your Microsoft Word document, you can see the corrections that they come up with. Sometimes it's all garbage, basically. So approximations are also a problem, but being precision is also a problem. So both are, so essentially, this is why this graph might be useful. You want to be somewhere in the middle. You don't want to be out here where you have underfitting. You don't want to be out here where you're overfitting. You want to be somewhere out here. Now, can you find that? That's the trial and error. And that's why someone asked me, do I constantly tune my model? Yes, you constantly tune your model because that's how your model will essentially keep performing as you move forward. Okay. I think I would like to stop at this point because I think I've given you enough of a background to just, get a sense of what's going to happen. So when now people come into this class, in the next few classes, people are going to go very deep into these things. Okay. So for example, in statistics, you will see so much, equations on regression and or so much on probabilities and so much on F statistics and P values and so on and so forth, so that you don't get totally drowned with what's going on with regression. I would like you to think in terms of the big picture also. What are we trying to really do, basically? Is it what you're trying to do is to come up with the best fit model? Well, it depends. If it can predict, basically, what we're trying to do is to see with what is the best model that will help me solve my problem. So that's why I remember I was telling you basically that don't get too bogged down on the algorithms and stuff like that. What you should be focusing on is basically whether does this algorithm work in real life. And that is not an easy task. And no one is an expert in that, basically. Okay, thank you all very much for your attention. So you will see, Dr. Ajay Kumar. And next week, I think it'll be Professor Karunakaran from, who will be talking about statistics. And after that, it'll be, I think, Professor Madhavan, basically, who will be talking about machine learning. But now things are going to build up, and now you'll go more deeper and deeper into, machine learning and predictive analytics and things like that. Okay.
Thank you, sir.
Thank you all very much. And you have a good weekend. And just hang in there. And if there's any questions that I can answer regarding the program or regarding anything that we have been talking about, or for that matter, for any faculty member or anything like that, please do feel free to reach out to me. You got my number. Do you have my cell phone number?
No, sir, I don't think so.
Okay, so let me just give it to you. It's 703, it's +1. Actually, I forgot to give you the the syllabus, right? The one that I didn't share with you. I think that has got my cell phone number. 70 +1 703 419 0165. So please send me a WhatsApp message, or of course, and also you can. I'm generally very good at email. You can send me an email at tksen.
I'll type it out.
Okay, tksen at bt.edu. Yeah, can you please send it to them?
Send it, sir.
Thank you.
Also, one more information. I've created a WhatsApp group for better communication, so everyone can be a part of the group in case, so that the whole thing runs smoothly. Right? And I've put my number there in the chat box.
Okay, good luck to all of you, and we will be in touch. Of course, you'll see more of me as we move along in the semester. But now I'll be handing it over to other people in the program. So hopefully you'll benefit a lot from the program. But at the same time, any questions, any confusion, do let me know. Okay. Thank you. Bye.
Thank you.
Thank you, sir.
Thank you.
You're welcome. Thank you.
Thank you, sir.